Greetings, everyone. Today we're going to take a look at graphing quadratics using standard form. You have two notes handouts as we are going to do two examples. They should be glued into your notebook and I will be checking these in class. Just a quick review. In the past we've graphed lines or linear equations, which are equations where the highest exponent is 1. We've graphed lines with shading, meaning we had linear equations with greater than or less than, and we had to shade to one side or the other. We've had absolute value functions, which in class we discussed are very similar to the rules of parabolas. So let's explore graphing using that parabola or U-shape. Just above your notes there, make sure you identify standard form. We've already used standard form in the last unit. And what that means is saying that f of x or y, remember function notation or y mean the same thing, is equal to a constant x squared plus a constant x plus a constant. So you'll have a leading coefficient in front of your x squared, you have a coefficient in front of your x, followed by just a number. Make sure you carry the signs with them, meaning you might have a negative b or a negative c. Let's take a look at this first example. Under f of x, please write the function x squared minus 4x minus 5. So we're going to graph this from scratch with no calculator. To start off with, in the past, we've come up with a table and we've just made one up. Don't write this down yet. Well, that's not very helpful because my U shape might be way over here, and then those values aren't very helpful. So what we're going to do is we're going to find the axis of symmetry using negative b over 2a. We discussed this in class using your foldable notes, so if you need to look up axis of symmetry to see what that means. So we want to use negative b over 2a. My b value is already a negative 4, so we know that a double negative becomes positive. Times 2 times a, technically my a is 1, which gives me 4 over 2, which is equal to 2. That means my axis of symmetry is x equals 2. So if I was to draw a dashed line, I know my parabola would fold or cut in half along that line, which means this value becomes your center x value. From there, you want to choose one point in each direction and then another point in each direction. Your work, you're going to take those x values and plug them in to the original function over here. So that means wherever there's an x, I'm going to put a 0. So I end up with 0 minus 5, so my y value is minus 5. When I plug 1 in, 1 squared minus 4 times 1 minus 5. 1 squared is 1. 4 times 1 is 4, minus 5. 1 minus 4 minus 5 gives me a negative 8. Make sure that makes sense to you with those negatives. 2, let's plug in 2. 2 squared minus 4 times 2 minus 5. 2 squared is 4. 4 times 2 is 8. 4 minus 8 minus 5. So 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. Let's plug in 3. 3 squared minus 4 times 3 minus 5. 3 squared is 9. 4 times 3 is 12. 9 minus 12 is negative 3. Negative 3 minus 5 is negative 8. Notice the symmetry that's happening here. This should always happen if you found that axis of symmetry first. So I'm going to make an assumption here that this should be negative 5, but let's double check. I end up with a 4 squared minus 4 times 4 minus 5, which is 16 minus 16 minus a 5. Yes, I'm right. I do get negative 5. Those are my coordinates. So let's plot those points on my graph. I have 0, negative 5. I have 1, negative 8. I have 2, negative 9. 3, negative 8. And 4, negative 5. Now make sure that when you connect these dots that it has a curve to it, right? I'm a little bit shaky here on my tablet, but you don't want it to be a V. Make sure you have arrows on the ends to show that it goes on forever, but make it a curve and not a V. Let's go through and answer some more questions. Opens. Remember the little rhyme, up like a cup, down like a frown. So I'm looking for if it's up or down. So in this case, we're opening up. That's all we need to say there. Here I've just carried the graph over. I had a Desmos version, so we're just going to keep using that same graph to answer the rest of the questions on your note sheet. The vertex. Vertex is a point. So vertex is right here at this exact point. We already have that point on our table. So if you look at your table, that point is at 2, negative 9. If you've done your table correctly, your vertex will always be that middle value. Axis of symmetry. We already found that. We already identified it on our graph, but we have to write it as the equation of a line, which is x equals 2. So make sure again that you had that dotted line on your graph to show the axis of symmetry. Maximum, minimum. Our maximum or minimum is our vertex. It's at the bottom. So in this case, it's a minimum, and it is at 2, negative 9. Notice that your vertex and your max and min are going to be the same. So what I'm looking for that's extra, is it a max or min? Your y-intercept. Your y-intercept is where it crosses the y-axis, which means you're going to have 0 for x and a number for y. Well, let's actually plug that in. If I plug in 0 for x into the equation, show this work, we end up with a minus 5. So my point is 0, comma, negative 5 for my y-intercept. Now you might be thinking, why do I need to show that work? Why do I need all of this work when I can just look at my graph and see it? Because sometimes you're not going to be able to just see it on the graph. Sometimes you won't have it on your table already. So still do the work in case you end up with a fraction or a decimal value. X-intercepts. Yes, on this one I can see my x-intercepts. But let's also show our work for this so we can keep practicing factoring. So what that means is if I take my equation and it's equal to 0, because remember x-intercepts are a number, comma 0. Your y value is 0. Let's factor. Let's use some AC method. 1 times negative 5 is negative 5. My middle term is negative 4, which means 1 and 5, and the 5 will have to be negative. Double check your work. 1 times negative 5 is negative 5. 1 minus 5 is negative 4. Again, that breaks apart my middle term. Now I'm going to use grouping because I have 4 terms. I can take out a 1x, which leaves me with x plus 1. Anything divided by itself is still 1. There's still a value that exists there. And here I'm going to have a negative 5 as a GCF, which leaves me with an x plus 1. I got the same thing twice, so if I factor that out, I end up with x minus 5 remaining, equal to 0. Set each factor equal to 0 and solve. we end up with x equals -1 and x equals 5. Now we stopped there last unit. Here we're referring to a graph. So write them as points. So I have a -1 and a 0, a 5 and a 0. Write it as a point to identify what it is on the graph. Couple more items to fill in. Let's talk about domain. Domain is always how far left to how far right. So maybe, again, write those arrows down as a reminder. We know that with parabolas, it's forever left, forever right. Because I copied from Desmos, just assume there's always arrows there. Your range is how low to how high. This graph goes as low, remember y values, goes low to -9 and up to infinity. -9 is included, so it does need a bracket. Intervals of increasing and decreasing. Now, we did not go over this in our notes, but it's exactly the same as absolute values. We read, just a reminder, add these in, read left to right, and always use x values. So trace it with your finger. I mean, I know it seems cheesy, but it's going to help you. If I start here and I'm tracing with my finger, I am decreasing. So where do I start decreasing? On the x-axis, I'm decreasing at -infinity, and I'm decreasing all the way to the x value of 2. That's where I'm decreasing. And then from 2 to positive infinity, I'm increasing. So I'm increasing forever to the right. So positive infinity, that is when I'm increasing. No brackets because I'm not increasing or decreasing at 2. It's what am I doing around 2, so we use parentheses. Take a moment to look over this example. Put stars by the sections that you struggled with. That way, when we look back to study, you have a reminder of where you really need to spend some extra time. Let's look through one more example. First of all, write down the function over here on the top left. You've got a -x² minus a 2x plus an 8. I want to make a table, but again, I don't want to start at 0 because what if my graph is way over here? So in this case, we want to use -b over 2a to determine my axis of symmetry. It's going to help me choose my key x point. My b value, if I label these A, B, C, my b value is -2, so I've got a double negative, which becomes positive, over 2 times A. My A value is -1. That negative makes a difference because now I have +2 over -2, which simplifies down to -1. So that becomes my axis of symmetry line and my center x value. For the rest, let's go 1 in each direction. So 0, let's go -2. 0 would be over here. It depends on how you count, up or down, it's up to you. -3, and then here +1. Of course, if you have that table flipped, that's fine. All right, let's show some work. Be careful as that negative is on the outside of that x². So in this case, I have a -3² minus 2 times -3 plus 8. -3² is +9, but I've got that negative lingering on the outside. Be very careful right there with those negatives. A -2 times a -3 is a +6, followed by a +8. -9 plus 6 is -3. -3 plus another 8 leaves me at +5. Let's take a look at -2. A -2² minus 2 times -2 plus 8. Negative 2 squared is positive 4. Then I have the negative on the outside. A negative 2 times a negative 2 is positive 4. And then I've got my 8. Negative 4 plus 4 is 0. 0 plus 8, 8. Negative 1. A negative negative 1 squared minus 2 times negative 1 plus 8. Negative 1 squared is positive 1. Get the negative remaining. Negative 2 times negative 1, positive 2, plus 8. A negative 1 plus 2 is 1. 1 plus 8 is 9. Now, if this truly is the axis of symmetry, I'm going to make a guess here and say 8 and 5. Let's see what happens. If I plug in a 0, the nice thing about zeros is signs don't matter. Because 0 is not positive or negative, so we'll just leave it as 0 minus 0 plus 8. So I know I'm right. 1. I've got a negative, a 1 squared, minus 2 times 1, plus 8. 1 squared is 1 with the negative outside. Negative 1 times negative 2 times positive 1 is negative 2, plus 8. Negative 1 minus 2 is negative 3. Negative 3 plus 8 does give me 5. So we're good to go there. Let's plot our points and see what it looks like. Negative 3, 5. Negative 2, 8. Negative 1, 9. 0, 8, 1, 5. So here we can see that if I draw my curve, I do end up with a downwards parabola. Why? Because it is down. Let me make that green to correlate, because this is negative. When the leading coefficient's negative, it's down. Well, guess what? That's exactly the same as absolute value rules. So we've actually already spent a lot of time on that. Same rule applies. Let's take a look at the rest of the questions. Your vertex, we've got that on our table. Our vertex is that point of negative 1, 9. Write it as a point. Axis of symmetry, handy, we already found that. It's x equals negative 1. Maximum or minimum. In this case, I have a maximum at my vertex, negative 1, 9. So maximums occur when it's down, and minimums occur when it's up. Y-intercept. If I am looking for my y-intercept, that means I plug 0 in for x, and I get a number for y. If I plug in 0, I actually already have that on my table. Still write it out though, because sometimes it won't be on your table. So in this case, we have 0 minus 0 plus 8. So I have 0, 8. X-intercepts. Now, yes, I know here on these slides, yeah, I can see them, but look at the graph you drew. Can you see the intercepts on your graph? In this case, you can't make any assumptions if you haven't got them on your table. So just as the previous example, we want to solve x-intercepts occur when the y value is 0. So I'm going to have my function set equal to 0. I'm going to have to factor and solve. First thing I'm going to do is I don't want a negative out front. So I'm actually going to divide everything by negative 1. That now creates x squared plus 2x minus 8 equals 0. Much easier for factoring. 1 times negative 8 is negative 8. Middle value is 2, which means I'm going to have a 4 and a 2, and the 2 is going to be negative. Check your work. 4 times negative 2 is negative 8. 4 minus 2 is 2. Those are my new middle terms. I now have 4 terms, so I'm going to group. I can take an x out of the first set and -2 out of the second set. Again, as I go through this video, if it's too fast, pause, take a moment to think about what we're doing. We've got the common factor of x plus 4. So if I factor that out, I have x plus 4 with an x minus 2 remaining. Set each factor equal to 0. We end up with x equals -4 and x equals 2. We write those as points, just like I've identified here. We have a -4, 0 and a 2, 0. Now, based on my Desmos graph, I know I'm right. Based on the graph you sketched, if you want to add these points on there and extend your graph, that would help it become more accurate. A couple more items to fill out. Let's start out with domain. Domain, again, is left to right. Forever left, forever right. That's always our answer on parabolas. Our range is how low to how high. This one goes forever down. So it goes from -infinity all the way up to my y value of 9. Remember, these are y values. These are x values. And at 9, it's included. Increasing, decreasing. We read left to right, and we use our x's. So if I trace, again, physically trace, if I trace, I'm increasing. I'm increasing from the x value of -infinity, and I stop increasing at the x value of -1. Then from -1 x value, I'm decreasing if I continue tracing. It helps draw these arrows on your graph. That visual can make a world of difference. Now I'm decreasing all the way to positive infinity. I know that's confusing because we're going down, but I'm talking x values. So I'm continually going to the right. The right is positive infinity. So take some time with those increasing, decreasing. Put a star by them if you need some extra help. I will check your notes next class, so make sure these are completed. Take some time to re-watch an example without writing, without doing anything else. Just concentrate on one example with no distractions. Keep factoring. We're going to have lots of factoring. It's not going away. We need to have this taken care of. And also, some of you are working towards reassessments and finals. So make sure that you're taking care of what needs to be done to end this semester on a high note. Let me know if you have any questions. We'll see you next time.